Before we get started, are there any questions on any of the assignments so far? Any questions over any of the homework assignments? So what we're looking at today is still dealing with solving logarithmic equations. Now we can consider log of 2x to have parentheses around it, but it is contained together inside the log. Now, one of the things I did mention yesterday was that whenever we're solving logarithmic equations, we need one log or have one log on either side. Now, since we do have a 2 here, we need all the logs to be together. We need just a singular logarithm. Now, this is going to be coming back to our properties of logs. If we have two logarithms that are being added together, we can rewrite it as a single logarithm with what's inside being multiplied. So we would say 2x times x minus 5 is equal to 2. Because if we have two logs with the same bases being added together, we can rewrite it as a single logarithm with what's inside each log being multiplied together. And whenever we have two logs or multiple logs being added or subtracted in a number, we need to simplify it down to one logarithm. Now, if we didn't have the 2, if this had been, say, 0, then I could have moved one log to the other side and gone from there. Or we could combine it and go from there as well. Any questions on what we did for the first step here? Now, after this point, it's going to be similar to what we did yesterday. We're going to put both sides to a base to get the log to simplify. Now, since this logarithm doesn't have a base written, it's understood to be 10. So here we can put both sides to the base of 10 because our log 10 to the log base 10 will simplify, leaving us with 2x times x minus 5 is equal to 10 squared. Any questions on this so far? Now, the left-hand side, we can distribute this out. We can do 2x times x is going to be 2x squared. 2x times negative 5 is negative 10x. Now, 10 squared is 100. If you don't want to have to copy all this twice, I can run a copy of it if you want when you get finished. Now, because we do have an x squared term, we need to get this equation equal to 0. So the next thing we can do is subtract 100 from both sides, telling us that 2x squared minus 10x minus 100 is equal to 0. Any questions on how we got this quadratic? Now at this point here, we could go about factoring. We can use the quadratic formula, or we can try graphing. Which one do we want to try first? Factoring. Now, if I look at this equation, is there a greatest common factor between all three or all four terms? This 2, 10, and 100 are all divisible by what? 2. So we can divide the entire equation by 2. 2x squared divided by 2 is x squared. Minus 10 divided by 2 is 5, so we have 5x. Minus 100 divided by 2 is 50. Now we can factor. Since the third term is negative, our signs are opposite. One's going to be positive, one is going to be negative. Now we're going to look at the factors of x squared, which are x and x. That's the only set of factors. Now the factors of 50, we have a few more. We have 1 and 50. 2 and 25. Will 3 go into 50? No. How about 4? No. Next one would be 5 and 10. 6 doesn't work, 7 doesn't work, and we're pretty much done. So we have these here. Which one do we want to try first? Most likely 5 and 10. The 5 would be positive and the 10 would be negative. Now, since we have two things multiplied together to equal 0, one of them must be 0. So for this one here, we would subtract 5 from both sides, telling us x is equal to negative 5. For the other one, we would add 10 to both sides, telling us x is equal to 10. Now, we do need to check it and make sure. Because whenever we're solving logarithms, it's good to sometimes check to make sure that everything does work. So the first thing we can check is when x is negative 5. And if we simplify this out, 2 times negative 5 is negative 10. Negative 5 plus 5 is 0. Well, we can't have negatives or 0 inside of a logarithm, so we can say for sure that negative 5 does not work, because that would give us an error. Anyways, now we can try this with 10. Log of 2 times 10 plus log of 10 plus 5 is equal to 2. Now that will give us log of 20 plus log of 15 is equal to 2. Sorry. I was wondering why this didn't seem right, and that's because this isn't plus, this should be minus, and that should be negative 10, okay, minus 5. Yep. Make sure everything else looks fine. 2 times x minus 5. And we can plug this into the calculator at this point. Log of 10 plus log of 5, not log of 20. And we do indeed get 2. So the solution that does work for this is x is equal to 10. Questions on any of this here? Now we could have tried plugging in the other one, log of negative 10 plus log of negative 10. Log of negative 10 plus log of negative 10 is domain error. It doesn't work. Any questions on these here? Are we ready for the next one? So we want to solve this here. Log base 6 of 6x plus log base 6 of x minus 1 is equal to 2. Well, since we do have two logs being added together, we can rewrite it as a single log with what's inside being multiplied together. Because again, since we do have a number by itself without a log, and we do have two logs, I need it as a single log equals a number. What would we do next? to simplify that log? We would put both sides to the base of what? 6. Because we need this 6 in log base 6. We need this log base 6 to simplify out. And to do that, once we do that, we'll have 6x times x minus 1 is equal to 6 squared. At this point here, we'll distribute 6x times x is going to be 6x squared. Minus 6x times negative 1 is negative 6x is equal to 6 squared is 36. Now at this point here, we need to get this equal to 0. So we can subtract 36 from both sides, telling us 6x squared minus 6x minus 36 is 0. Now normally we said if we have a number in front of x squared, then there's a good chance our solutions are going to be fractional. We'll have at least one fraction, yes? Is there a greatest common factor between the three terms? 6. So will the number in front of x squared stay 6? No, it'll turn into just x squared. It'll turn into 1. So we could graph this, because we could leave it as 6x squared minus 6x minus 36 and graph. It looks like it does intersect at 2 nice points. If we go second table, well, the 2 points that it does cross the x-axis where y is 0 is at negative 2 and 3. So it's saying x is equal to negative 2 and x is equal to 3. Almost got it. 100% 6, it's equal to 2. Now between these two here, which solution do we think is probably not going to work? Probably the negative 2. And if we plugged it back in, log base 6 of 6 times negative 2 plus log base 6 of negative 2 minus 1 is equal to 2. And if we simplified this here, we'd have log base 6 of negative 12 plus log base 6 of negative 3 is equal to 2. I have 2 spots where we have a negative inside the log. You want to go? And it's not so much that the starting number was negative is the issue. It's that the finishing number, that once we finish simplifying, these 2 spots here both ended up being negative. Now, if it had worked out, then we plugged the negative number in, we simplified down, that the 2 spots here, and here, worked out to be positive numbers, then it would work out. It's just the fact that they both ended up being negative that we have an issue. Because we had one on the homework where the 2 solutions were both negative, but when we plugged it back in, the number we ended up getting was a positive number. And I believe it ended up being positive 9 in both cases, and does simplify. Now if we do the same thing with, let's go blue, 3, log base 6 of 6 times 3 plus log base 6 of 3 minus 1 equals 2. And when we simplify, we get log base 6 of 18 plus log base 6 of 2 is equal to 2. And if we notice here, this time 18 and 2, they're both positive. That's what I'm really looking at, is once we plug it back in and simplify down, are the numbers that finish out in both logarithms, are they both positive and different from 0? And we could plug this in and we'll see that this does work. So it tells us that negative 2 doesn't work and 3 does. Any questions on this here? Any questions over anything we've done so far? How do we feel with solving them with addition? Okay. I think we feel comfortable with these here, yes? Since we feel comfortable with those, we'll move on to subtraction. Now, as you notice that it went from the book's kind of text to my own handwriting, because the textbook doesn't talk about these too much, but it's not because they're any harder. They're just a little bit different. Because again, just like with addition, as we did on the previous ones, I need to make this into a single logarithm. Now, if we have two logs being added together, it can be rewritten as a single log with what's inside being multiplied. If we have two logs being subtracted, we can write it as a single log, but what's inside of it is not being multiplied anymore. It would be what? Divided. So we're going to say that we have 3x minus 2 over 2 is equal to 3. Now, the rest of the steps going forward are going to be pretty similar to what we've done before. At this point here, we need to put both sides to the base of what? 10. Because here, the 10 to the log is going to simplify out, leaving us with 3x minus 2 over 2 is equal to 10 cubed is 1,000. And it does work out. The exponent that is attached to 10 tells us how many zeros that we have. Any questions on this so far? What do we think we should do next? Huh? We can, yes. I would do that especially if we did have an exponent. But the biggest thing is this fraction, yes? We can multiply by 2. So we could have subtracted the 1,000 from both sides and then graphed it, and it would give us an answer. But here, I'm going to go on and just multiply by 2, because these will cancel, telling us 3x minus 2 is equal to 2,000. Actually, we can go here. What can we do next? We can add 2 to both sides. Telling us 3x is equal to 2002. And last but not least, we can do what? Divide by 3. Now, will 2002 divide by 3 evenly? No. So we have 2002 over 3 as our solution. Is it 3? Because we had log of 3x minus 2 minus log of 2 equals 3. Now we can check it just to make sure that this is the correct solution. So we can plug it in. So we say log of 3 times 2002 over 3 minus 2 minus log of 2 is equal to 3. Well, if we're simplifying, the 3 and 3 would simplify, telling us that we have log of 2002 minus 2 minus log of 2 is equal to 3. Or really, to fully simplify it, we have log of 2000 minus log of 2 is equal to 3. And once we finish simplifying both of the numbers inside the parentheses, they are both positive, yes? So that's fine. If we wanted to plug it into a calculator, we can say log of 2000 minus log of 2, enter, and it is indeed 3. So as not nice as that number is, 2002 divided by 3 is the correct answer. Questions on this here? Well, the only reason we didn't have an x squared term is because we only had x to the first. We never had an x times x, so we didn't get 2 solutions. We only get 1 here. Questions on any of this here? Get ready for the next one. Log base 4 of x minus log base 4 of x minus 1 is equal to 1/2. Well, just like with the previous one, we can rewrite this as a single log. So we have log base 4 of, now because they're being subtracted, we would have division. Log base 4 of x over x minus 1. At this point here, we're going to put both sides to what? Base of 4, because we want this log to simplify. 4 to the log base 4 will simplify out, leaving us with x over x minus 1 is equal to 4 to the 1/2. Well, the question is, will 4 to the 1/2 simplify nicely? Because the 1/2 exponent is the same as the square root. So we're really asking what is the square root of 4, which is 2. Questions on any of this here? At this point here, we're going to do something similar to the last one, but instead of multiplying both sides by 2, we're going to multiply both sides by what? X minus 1, because here the x minus 1 and x minus 1 will cancel, telling us x is equal to, here we can distribute 2x minus 1. What can we do next? What can we do next in solving for x? Right, we can subtract 2x from both sides. Because 2x minus 2x is 0, leaving us with -1. On the other side, x minus 2x is -x. Now, as we've said, most of the ones that we've done so far, having a negative value is not helpful. But is x by itself? No, we still have the negative, yes? So to finish solving, we need to divide both sides by -1, telling us x is equal to 1. So we had log of x minus log base 4 of x minus log base 4 of x minus 1 is equal to 1/2. Now the solution that we found was 1, and we could plug it back in and check. Minus log base 4 of 1 minus log base 4 of 1 minus 1 is equal to 1/2. That'd be log base 4 of 1 minus log base 4 of 0. So does 1 actually work? Because we can't have 0 inside of a logarithm. x4, and I believe it was x minus 1, yes? Because we don't have a value at 1, we have a value at 2. Oh. This does work. What's 2 times negative 1? Negative 2. That means x is not 1, x is 2. So when we plug it back in, we'd have 2, 2 minus 1. So this does work, so 2 is the correct answer. And partly we can see it here on the graph, because when x is 2, the y value is 0.5 or 1/2. So it does work. If I wanted to draw 2 equations, here, second trace, intersection, to move this over so that we do get enter, enter, enter. They do intersect when x is 2 and the y value is 1/2. So x equals 2 does work. Questions on any of this here? We kind of get this here besides the one calculation error. Any questions over anything we've done so far? Do we feel comfortable with these here? And that's it. So your assignment for this here is on page 341, 33 through 37.